Hi everyone. Today I discussed about beam problem in third unit. So here the problem statement is a rectangular concrete beam is pre-stressed by means of 15 wires of 5 mm diameter located 65 mm from the bottom of the beam and 3 wires of diameter 5 mm and 25 mm from the top, assuming pre-stress in the steel as 840 Newton per mm square. Calculate the stresses at the extreme fibers of the midspan section when the beam is supporting its own weight over a span of 6 meters. Evaluate the maximum working stress in the concrete. The density of concrete is 24 kilonewton per meter. Here they have to calculate stresses at the extreme fibers of the I section. So, how to calculate the extreme stresses in pre-stressed concrete structure? There are 4 types of stresses will be acting. First stress is due to pre-stressing, second stress due to eccentricity, third stress due to dead load, fourth stress is live load. Here how much is the live load will be acting? Live load will be acting only here. Dead load will be only given, so that is the 24 kilonewton per meter square meter cube, and pre-stressing is given by 840 Newton per mm square. That 840 Newton per mm square will be converted into pre-stressing force. That is the given problem that they have to draw. So 6 kilonewton per meter. So they are given 6 kilonewton per meter as a live load, and width of the beam is 200 mm and depth of the beam is 300 mm, and eccentricity from the bottom of the effective cover is 65 mm, on top is taken as 25 mm. Bottom they have to provide 15 number of bars of 5 mm diameter. Top they have to given 3 number of bars 5 mm diameter. First of all, here we have to calculate y dash. So why we need to calculate y dash? Y dash means eccentricity will be acting at top and bottom of the member. So the y will be taken as from bottom to from the neutral axis of the beam. So 15 number of bars of 65 mm diameter depth, and total depth we have to remove the among the 300 mm, 25 will be removed by 275 mm from the bottom. So we have to calculate y dash is 100 mm, then eccentricity will be 150 minus 100, that is equal to 50 mm. Area of tendon we have to calculate. So they have to given total 18 number of bars, that means bottom they have to provide 15, top they have to given 3, so total is 13. Mottam total 18 number of bars of area of section is 353.43 mm square. Then we know the calculation of pre-stressing force, that is capital P. The pre-stressing force is nothing but stress into area. Stress into area. Stress is 840 Newton per mm square. Area is 353.43 mm square. Then we have to calculate pre-stressing force, that is 3 into 10 to the power of 5 newtons. Then calculate the total area of the concrete member, that is 300 by 200, total is 6 into 10 to the power of 4 mm square. Next we have to calculate Z. First of all we have to calculate moment of inertia BH cube by 12 for rectangular section. B is given 200, H is given 300, total 200 into 300 square by 6, that is considered as Z. That is finally we get by the calculation 3 into 10 to the power of 6 mm cube. Self height of the beam, we know they are given 24 kilonewton per meter cube as a self density of concrete, then converted into self height of the beam, multiplying with area of cross section, that is 300 mm, 200 mm, that will be converted into meters. 0.3 into 0.2 into 24, that is 1.44 kilonewton per meter. So next we have to calculate self height moment. So moment due to self height, we know the simply supported beam with UDL. The formula is WL square by WL square by 8. So W is 1.44 into 6 square by 8, we will get 6.48. 6.48 kilonewton meter. Then calculate live load moment, that is also WL square by 8. For that, in that problem, live load will be given 6 into 6 meter square by 8, that is 27 kilonewton meter. So then we have to calculate top stresses. So top stresses we have to take in as minus P by A plus PE by Z minus Mg by Z ML by Z. So by the calculation we substitute P value is 3 into 10 to the power of 5, area of cross section is 6 into 10 to the power of 4 plus P into 3 into 10 to the power of 5 is taken as 50 divided by Z value is 3 into 10 to the power of 6, and moment will be calculated as before earlier 6.48 into 10 power 6, and Z is we will get 3 into 10 to the power of plus 6 minus 27 into 10 to the power of 6, 3 into 10 power 6, that is we will get 11.16 Newton per mm square as a top fiber stress, and we have to calculate bottom fiber stress. In that bottom fiber stress, the formula is given minus P by A minus PE by Z plus M by Z plus ML by Z. So then we substitute the values of the P value, that is pre-stressing force, and area of cross section 6 into 10 to the power of 4 minus 3 into 10 to the power of 5 into eccentricity is given in problem, that is 50, and denominator Z value substitute 3 into 10 to the power of 6. Finally we get bottom fiber stress is 1.16 Newton per mm square. So as final conclusion of this problem, top fiber will be in, that is minus 11.16 Newton per mm square, bottom fiber is 1.16, that is positive. So negative we have to take in as tension and positive we have to take in as compression. So at the bottom we will get positive value, that is 1.16 Newton per mm square. So each and every problem we have to substitute like this, we will get. So finally we get top and bottom stresses, then we have to draw the stress diagrams for this above problem. So it is the problem. By the calculation we will get stress due to pre-stressing force, that is 5 Newton per mm square, stress due to eccentricity, that is also we will get PE by Z 5 Newton per mm square. So next we will get bending stress due to dead load and bending stress due to live load, the resultant stress like this. Top fiber is taken as 7.16, bottom stress will be taken as 1.16 Newton per mm square. So next topic we have to discuss about thrust line. So what is meant by thrust line? It is very important topic in prestressed concrete in third unit. So in previous problem we have to discuss different types of stresses. That is, first one is stress due to pre-stressing force, second one is stress due to eccentricity, next one is stress due to self-weight, and fourth one is, last one is stress due to live load. So in that beam we are calculating different types of stresses in a particular section. So each and every stress will be acting in different perception. Based on that we have to calculate pressure line. So here at any given section of pre-stressed concrete beam, the combined effect of pre-stressing force and externally applied load will result in a stress distribution of concrete stresses that can be resolved in a single force. So four types of stresses will be acting in concrete beam, pre-stressed concrete beam, that will be acting in different places, different points. Based on that we have to calculate single force that will be obtained this topic. The locus of point of application of this resultant force in any structure is termed as the pressure line or thrust line. So finally the conclusion is the pressure line will not be passing in the center of the beam. It is some positions of the beam will be moved. So that points we have to identify, and based on that we have to indicate the location of the pressure line. So that is the pressure line. So pressure line will be located in different positions of the beam. That particular point we have to identify. So here at any given section of pre-stressed concrete, the combined effect of pre-stressing force. So different types of pre-stressing force, that means stress due to loads, stress due to forces, and stress due to self-weight. In stress due to pre-stressing force and eccentricity is one classification. Stress due to live load and dead load will be another criteria. So in different criteria point aspect of loads or stresses will be acting in the beam, that will be classified as in different locations, that we have to identify the locus of the point of application of the result. So that locus of the point of application of the result will be identified this topic. So next this problem we have to study in next class. Write down this problem, we have to discuss in class. So this problem related to pressure line. So a pre-stressed concrete beam of section 150 mm by 300 mm deep is used over a effective span of 6 meters to support a uniformly distributed load of 4 kN per meter, which includes the self-weight of the beam. The beam is pre-stressed by a straight cable carrying force of 180 kN and located at an eccentricity of 50 mm. Determine the location of the thrust line in the beam. Plot the position at quarter and center span. So here we have to take in as 150 mm by 350 mm and effective forces, pre-stressing forces 180 kilonewtons, 180 kilonewtons with an eccentricity of 50 mm. Determine the location of the thrust line. So here we have to identify the position of the pressure line in the above cross section of the beam. The beam is given by 120 mm, 300 mm and L is given 6 meters and live load is 4 kilonewton per meter. So as we have to calculate before problem, as is this problem same we have to doing like that, and at the second point we have to calculate the position of the pressure line. So it is the area of the member and force is given, F is 180 kilonewtons, eccentricity is 50 mm. So midspan is calculated WL square by 8, location of the thrust line M by P, that is 100 mm. At quarter span we have to calculate WL square by 8 and we will get 75 mm. So like that we have to do the problem. It is very simple and it is this problem will come number of times in previous question papers. You have to refer and complete this problem in notes. So thank you.